Okay, so do you guys recall how to go from a pitch to a slope?
No.
Um,
No. Put it 4 over 24 and then you.
so anyway, yeah, you are correct. We do have to take the 4. We ignore the 12. It has to be a 12 on bottom, but we're not going to use the 12. You take the 4, it's over 24, and then reduce. Both of those can be divided by 4, so it gives us a 1/6 pitch. Any questions on that? So what do you get for this other one? 7 over 24. There's nothing you can do with that one. So what if it were an 8/12 slope? Convert that into a pitch for me quick. So this is 8 over 24. That reduces to a 1/3 pitch. Very good. So down bottom here. Any questions on going from slope to pitch? So it has to be a 12 on bottom, but we're not going to use the 12. You just take the top number, put it over 24, and reduce. The other way you could do it, by the way, is you could take the 4/12, and you could multiply by 1/2, which becomes 4 over 24, and then reduce. That works the same too. So down here, to take a pitch and turn it back into a slope. A 1/2 pitch, you're going to multiply by 24 over 1. 1/2 times 24 is 12. That is a 12/12 slope. 1/6 pitch. What are we going to do with it? Times 24. 24 times 1/6 is 4, so that is a 4/12 slope. Questions? So convert 2/3 pitch into a slope for me quick. What's that? 2/3 pitch, standard pitch. Our pitch is always height over span. So 2/3 times 24 is going to be 48 over 3, which is 16. So that's a 16/12 slope. On slope, you always leave it over 12. For pitch, you reduce. Slope is always out of 12. Now, I will warn you, in the industry, people use the terms very loosely. Like it's not on, well, it's very, very common for someone to say it's a 4/12 pitch. 4/12 is not a pitch. 4/12 is a slope. Well, you're still in the construction program. So 10/12 slope, convert it to a pitch, and a 1 pitch, convert it to a slope quick. Make those work in your notes for me. It's a 1 pitch, yep. What'd you guys get?
A 12 and a 24 over 12.
So yeah, 10, 12. It's going to be 10 over 24, which reduces to a 5-12 pitch. The reason I brought this one up is this one can be very confusing because when you see that 5-12 pitch, you instantly want to go to a 5-12 slope. So that's why you can't just assume that when they say pitch, they mean slope. You got to make sure you clarify. By the way, symbols, for those of you who haven't seen them yet, if you have a truss like this, if you have the drawing of a rafter, a symbol like this, that indicates that this is, that symbol, if you see it, indicates that this is actually a 5-12 slope. A symbol that looks like this, whatever number is here, sometimes it's written like that, sometimes it's written, most often it's written like this. That's a 1/2 pitch. With the full triangle like that, the full isosceles triangle. Okay, what'd you get for the one pitch going into a slope? 24-12 slope. Very good. Okay, well, the next thing we're going to look at, we looked at it briefly last class. Looking at the framing square itself, the wording on the framing square and how it works. The top line, of course, on your framing square is length common rafter per foot run. And what that is that saying is, if you have a rafter that runs a certain distance. So let's say this here is a 30-foot span. What's the run? 15 feet. If it's a common rafter, that means that the peak is in the middle, so the run is always going to be half the span. I don't have, there's one in your packet that I gave you on page 266, so you can look at it. But I took mine home last spring to do some work, and I forgot to bring it back in. So let's say that this is a 6-12 slope. So what you're going to do is on your framing square, it's that top line that says your length of common here. And what you're going to do is you're going to follow that over to the 6, because that 6 represents the 6-12 slope, not pitch, slope. So you follow that over to the 6. So if you're actually in your packet on page 266, on the bottom there, they've got one. So we're looking to find the 6-inch mark. That's also your 6 slope. Down below that, it says 13 space 42. We discussed this last week. That's really 13.42. They just don't machine the decimal points into it.
So what's the numbers below it?
We'll get to those in a minute. We'll get to those. What does this 13.42 mean then? Well, it means for this situation here where we have a 15-foot run, the length of the rafter right here is found by taking 15 feet times 13.42. Now this is going to give us the length of that rafter in inches. So 201.3 inches. Now we have to convert that back. So this is a good exercise for us right now, taking inches, and we're going to go feet, inches, and eighths. Same process would apply for feet, inches, and sixteenths. So we're going to start out with 201.3 inches. What I'm going to do is in my calculator, I got 201.3. I'm going to do this. I'm going to divide by 12. It gives me 16. Notice all I wrote is the 16. Nothing else. So back to my calculator, I got 16.775. I'm going to subtract the 16. Now I'm going to turn that back into inches. I already took the full feet off, so I'm going to multiply by 12. Notice I have not cleared or done anything. 16 feet is 192 inches. So there's 9 inches left over. So this is telling us there's 9.3 inches left over. So I have 16 feet. I have 9 full inches. So back to my calculator. 9.3 inches. Next, I'm going to get rid of the 9 whole inches by subtracting 9. So I have 0.3. How do I turn 0.3 into eighths? Times 8. Gives me 2.4. That's telling us between 2 and 3, it's closer to 2/8, which is going to reduce to 1/4. So I have 16 foot, 9 1/4 inches. So using the framing square is useful, but it's even probably more useful to learn how to do this feet, inches, and eighths conversion from decimal inches. Calculator? It doesn't matter. It depends on who you're working for. On our next example, we'll do in 16ths. It works the same. So let's say we're given that the span is 42 feet and the slope is 9/12. To find the length of the common, we're going to look up 9/12 on the framing square. You get a 15 is what that says on the framing square. So what are we going to multiply by 15? 21. Our run is half the span. So 15 times 21 is 315 inches. So on my calculator, I'm going to take that 315 inches and what am I going to do? I'm going to divide by 12. Very good. Gives me 26.25, so that's 26 feet. Then what? Subtract the 26, and then times 12 puts us back at 3 inches. So that's 26 feet, 3 inches. So that one didn't need to go to eighths or sixteenths. It came out to an exact inch. Let's do 8/12 slope and 18-foot run. So 8/12 gives us what on the framing square? 14.42. Good. What are we going to multiply that by? Yeah, I gave you the run, not the span, so it's 18 times 14.42. So we got 259.56, and you're correct. We're going to divide by 12 to make it feet. Gives us 21.63 feet, so 21 feet. So subtract the 21. We're going to do 16ths on this one. So I subtract the 21, then times 12. So I now have 7.56 inches, so I take the 7 inches. Subtract the 7, and we're going to go to 16ths this time, so we're going to do times 16. 8.96 or 9/16. Yep. So we got the 18 times 14.42. So we get the 259.56, right? So first thing I'm going to do is I'm going to divide by 12 to put that into feet. So 21.63 feet, right?
Oh, I know I did wrong. Never mind.
So I'll just finish it off. So I'll subtract 21. Got 0.63 times 12. So we get 7.56. What's that?
I said 18 was a span.
No, 18 is the rod. Yep. So I'm going to subtract 7 and then times 16 for 16ths. So 9.6. So I want you guys to try one. Actually, I better do one more example. I'll do one more example. Span of 28 feet, and I want it to be a one-third pitch. Don't have a 1 on your thing. No, you don't, but 1 doesn't work. It's pitch. So our first thing is we got to convert 1/3 pitch times 24 is going to give us 8, so that's an 8/12 slope. So we look up the 8/12 is 14.42. What are we going to multiply by 14.42? 14, which is going to give us 190. 201.88. Okay, so we're going to take that 201.88 and divide by 12. We're going to go 16ths. So 16 feet. We'll subtract the 16. Multiply it back by 12. 9.88. So 9. Subtract the 9. Times 16. 14. So that's 14 16ths or 7/8. Okay, I'm going to have you guys try 2 of them on your own here. So find the length of the common for that one and for this one. Okay, let's see how you did. For the first one, 712 slopes, you look that up and you get what on the 13.89. That's going to be multiplied by 36. Say no.
No.
Multiplied by 18. Very good. So 18 times 13.89. 250. So we go through the process. Divide by 12 to make it feet. It's going to be 20.83. So 20 feet. Subtract the 20. Times 12. Oops. I got something wrong there. 0.835 times 12. Get back into it here. 10.02, so that's 10 inches. I'm going to subtract the 10. And then times what? We're going to 16ths, so times 16. So 0.32, so there's no 16ths. 0.32 is less than a half a 16th, so it's just 20 feet, 10 inches. How many had that for the first one? A couple of you? Anybody have no clue how I got that? No clue? Do you see where the 13.89 came from? Okay, you got your packet with you? Page 266? Okay, go down to the bottom where you see the framing square thing there, right? There's the 712, so you find the number 7 on top there, where it's, you got 12, 11, 10, 9, 8, 7. The top number below the 7 is 13.89. Because that's the row that has the length of the common. The other rows mean something else. Well, then you'd have to either have a different piece of paper or you'd have to have the square in front of you to look at. There are other views of the square later on in the packet. Actually, most of them do show the 5 through, basically show 5 through 12. So I guess we're going to try to keep all of our examples between 5 and 12 for slope. No 412 slopes for us for right now. I say even the one in your little book, it goes 5 through 12. So apparently that's the one they want us to work with. So for the second one, it's a 1/4 pitch on a 24-foot run. So what do we have to do before we do anything else? We got to change that to slope. So what do we do with the 1/4? Times 24 gives us 6. That means this is a 612 slope. So we look up the under the 6. What do we get? 13.42. Good. And that's going to multiply by the run. So is it 24 or 12 that we're going to use? 24 is the run, not the span. So 24 times 13.42 gives us 322.08. Are you good with us so far, Sean? Does that make sense? How about this process now of converting it down into feet and inches and 16ths? All right, so it's got to divide by 12. So we got 26 feet. So we're going to subtract the 26 times 12 to turn it back into inches. 10.08, so that's 10 inches. So we'll subtract the 10. And then times 16, so 0.08 times 16 is going to give us 1.28, which is between 1 and 2, but it's closer to 1. So 1/16. Is there anybody out there right now who thinks they have no chance of being able to come up with this on their own? You're doing better on your own without my explanation? No, that sometimes happens. Yes, sir.
So, how did carpenters using the framing square come up with the length of rafter without having a calculator at hand?
Piece of board and a pencil.
No shortcut. They had to do everything we're doing.
They would have done this. They would have taken that 13.42 times 24. This is 8, 16, 13, 9, 0, 4, 8, 6, 2, 8, 0, 1, 2, 16, 3. Did I multiply that right? I don't think so. Did I? 362.08. Now what they would have done is this. Most of them knew that 360 inches is 20 feet. So they'd taken out 20 feet and then subtracted 360 inches. What's that? I was going to say, I did something wrong there. But let me remultiply that. Don't know what didn't come out there, but it's not coming out. So let's try that again. 24 times, so that's 8, 16, that's 13. That's going to be 5. That's why. So 0, 2 times 4 is 4, 8, 6, and 2. This is 8, 10, 12, 12, 322.08. Yeah, so they would have looked at that. They know that 360 is 30 feet. 48, 312 is going to be 26 feet. So this 26 times 12 is 312. So they subtract 312, gives them 10.08. So that's 10 inches. And then they know the 0.08 times 16 is 1.28. So that's going to be 1/16.
Okay, so this was muddying the water even more. What's the rest of that column of numbers underneath the 7 or the 8?
Okay, well, we're going to get to some of the rest of those. Not all of them.
All right.
But we'll talk about some of them. The next 2 rows are for hips and valleys. And we'll talk about hips and valleys.
Did I ask them?
Well, we'll talk about hips and valleys a lot more next semester. But hips and valleys are when the roof, most roofs, if you're looking at them from the top, the peak goes all the way out to the ends, right? A hip roof, what happens is you get to the edge and they actually chop it off and it slopes down. So if you're looking at it from the front of the house, instead of the roof looking like this, at the front of the house, the roof looks like this. Does that make sense at all?
Yep.
Actually, kind of like I've got a model here somewhere, I think. Like this. This one's falling apart, but you get the idea. And the same goes for a valley. The valleys have shorter. So what has to happen here is your common rafters, if you're going to do, make sure this is hip on both ends, your common rafters is what we just calculated fit in here. There's also, and of course on the other side here, there's also one other spot where a common rafter fits. In the hip here, this first hip jack, they call it, is the same length as the common. If this is what they call a conventional hip, and for right now we're going to assume it's conventional hip. By conventional hip, I mean that whatever the slope is here on the main roof, you have the same slope on the hip. So if it's 612 slope on the main roof, it's 612 slope on the hip. So if we have that conventional hip, that first hip jack is the same length as the common. So what the next 2 rows are, if you look up above on page 266 in your packet, it says length, hip or valley per foot of run. So those numbers should be the same. The second row is actually this corner, the hip rafter is what they call it. So if you have, and you notice that number is bigger than the top number, because that rafter will be longer than the common. So let's just take a look at a hip system here quick. So let's say that this is a 6/12 slope in both directions. And let's look at it from the top as well. We're going to ignore overhangs for right now. We're just going to say that this is 32 feet. So what that means is if that's 32 feet, this distance here is half of that is going to be 16 feet. If it's conventional, if the slopes are the same in both directions, this is called the setback, is always half the span. So length of common. Well, we look up 612. What do we find? Under 612, we get 13.42 times what? The span is 32, so it's going to be times 16. So 16 times 13.42. 214.72, so I'm going to divide by 12. 17 feet. So I'm going to subtract the 17 times 12, put it back in inches. So 10 inches minus 10 times 16, 11.5, so 12/16 or 3/4 of an inch. So that's the length of the common rafter. The length of the main hip rafter here is the same. It's not the main hip rafter, it's the main hip jack. So the main jack. Got to make sure I'm using the right terminology here. The hip rafter itself, the corner rafter, is going to be 16 still times the second number there is, under 612, is 18. So you multiply that out, we get 292 inches. Oops, sorry, 288. The reason I double checked that, I knew that. So now we're going to divide that by 12. Get exactly 24 feet. So the hip corner here, the hip rafter, is 24 feet long. Now the third number, if you look there, the third and the fourth rows, the third row says difference in length of jacks. That says 10-inch centers. That should say 16-inch centers. That's a misprint. Difference in length of jacks, 16-inch centers. And then the fourth row has little hash marks. That says difference in length of jacks, 2-foot centers. So it depends on whether your jacks are spaced 16 inches apart or 2 feet apart. And what that tells us is, as we go from this longest jack or the common rafter down, the next one is going to be a certain length shorter here. That amount is the same from one to the next, no matter which one we're at. So this difference here will be the same as this difference here. So that is telling us, if we use the third row, which would be 16-inch centers, that if the rafters are spaced 16 inches apart, that third row is telling us it's 17 and 7/8 inches difference. I don't know why they choose to put those rows in fractions instead of decimals, but they do. So what that is telling me is my longest jack is the same as my common, is 17 feet, 10 3/4 inches. Each jack after that, each of the shorter jacks will be 17 and 7/8 inches shorter, or 1 foot, 5 7/8 inches shorter. So we're going to subtract 3/4 minus 7/8. We're going to borrow. This will become 9 inches. This is 7/8 of an inch. 9 minus 5 is 4. 17 minus 1 is 16 feet. So the next jack will be 16 feet 4 7/8. The next jack, you'll subtract another 1 foot 5 7/8. Remember, that comes from the 17 7/8. We subtract the same each time. So the 7/8 is 0. We're going to borrow. This will be 15, and this is going to be 16 inches. So 11 inches. 15 minus 1 is 14 feet 11 inches. And you keep subtracting. You can find the length of all of the jacks that way. Now the 5th and 6th rows are side cuts for the jacks. And what they are saying is, like 7 7/8, what that is telling you to do is that's telling you to take your square, go to 12 inches on one side and 7 7/8 inches on the other side. And you're going to lay your board, your jack across it like this. This angle right here is the angle you're going to cut that jack so that it fits up against that, up against the corner rafter right here. Okay? What do you think?
This isn't gonna be on the cut.
There might be a quiz on this.
What? On this or on what we learned the first drill, not the second drill?
The quiz for right now will just be on the first couple rows. I'm going to give you the next 10 minutes to work on this, then we'll come back in the second hour. We'll discuss it some more. So in the packet, you do have page, let's see here. It's on the bottom of page 282. There's just problem number 1. Wow, I really went all out on homework for you. Page 282 of the packet.
Okay.
Problem 1, parts A and B.